So continuing where I left, um, as I said, if it's ionic, then it would be beyond the scope of just a kitchen chemistry experiment to identify the substance. If, on the other hand, if it's some kind of organic compound that doesn't dissolve in water, then I can definitely determine its density and as well as its melting point. So density is a really good way to identify any substance. Once you know the density, you can compare it with the known values through an internet search and identify the substance, all right? Boiling and melting points for solids, and then of course boiling points for liquids are the other ways to confirm that your unidentified substance is what you think it is. Real world use for it is if suppose somebody accidentally ingests a substance and is unsure what it is, one way to find out is to take a sample of that substance and determine its density and compare it with some known value. Again, an unknown liquid, again, the density or the boiling point. Odor is another way to tell whether liquid is organic or inorganic. Inorganic liquids may or may not have an odor, but organic liquids a lot of the times have some kind of odor associated with them. But again, to really confirm what that liquid is, density and boiling point would be the best ways to confirm the identity of that liquid. Some real-world applications of identifying unknown compounds and liquids. Suppose someone is arrested with an unknown white powder. Is this powder sucrose, as the person claims, just table sugar, or is it cocaine, as the police might suspect? Do a solubility test. If it is sucrose, it's going to dissolve right away into water, all right? Then determine density of that solid, especially if it doesn't dissolve in water. You can do the same water displacement method to determine its density. Melt it down, determine its melting point, and then compare it with the known literature values of sucrose and cocaine. So also if somebody has ingested something and died, and you want to find out the identity of that unknown substance ingested that caused the death, again, this is a way to do a quick identity test for that unknown substance. Some pharmaceutical health related uses, all right? So we have some natural material which shows a powerful cancer inhibiting properties in rats. So we have to pinpoint which of those chemicals in the sample has those anti-cancer properties, and then determine what its structure, whether it can be artificially synthesized. So the first thing to do is to take a bit of that sample material and analyze it using the physical chemical methods. All right, so first you start out with these physical methods like density and melting point, etc., and then you proceed to the chemical methods to make to confirm the analysis of that substance. Health and nursing related. Suppose you're given a couple of bottles of clear liquids, all right? One might be harmless and benign as water, the other could be methanol, all right? And then methanol is really toxic because it can cause blindness and death depending on the amount consumed, all right? So again, a quick way to make the identity and confirm the identity of these liquids would would be to do the density analysis, followed by the boiling point analysis, and that way you can distinguish between the two liquids. Some toxicology and health related uses of identifying unknown compounds and liquids. Suppose a patient ingested a substance and got very ill. You can obtain a sample of the substance the patient claimed had ingested and conduct all these preliminary tests like solubility, density, melting point if it's a solid, or density and boiling point if it's a liquid. And then once you've confirmed the identity of the substance, you can then determine what course of action you need to undertake to treat that patient. And that's all for this video, and that concludes this lab discussion.